needed for mountain railway alignment optimization. Here comes our method that proposed by 2017. For all optimization studies, there are mainly two problems that need to be solved. First is to determine the optimization model. Then is to develop an optimization algorithm to solve the model. The optimization model firstly includes three parts: the design variables, the optimization, the object function, and several constraints, design constraints. For railway alignment design, the design variables mainly refers to a series of geometric variables, that is the coordinates of the horizontal point of intersection, or horizontal intersection of points, and the horizontal radius of horizontal point of intersection, and the mileage, or more specifically, the station of each vertical point of intersection, and the design elevation of each vertical point of intersection. Thus, the railway alignment design problems use 5 sets of vectors as the design variables. The objective function in this study mainly refers to the comprehensive cost of a railway, that including the construction cost, operation cost, and the environmental impact cost. The construction cost, including the cost spending on constructing bridges, tunnels, earthwork sections, including the cut and fill sections, and the length dependent cost. This is mainly for building tracks. And lastly, the right of way cost. These are the construction cost, and it is multiplied with a factor. This factor is usually set at 0.06 in China, and these are the operation costs that are related to alignment angles, related to the vertical gradients, and related to the alignment length. And finally, this is the environmental impact cost. The constraints in this study include geometrical constraints. This constraint mainly refers to the codes or specifications when designing a railway, and the location constraints, such as the forbidden zones and the crossing constraints. For example, when crossing existing railways or rivers or roads, the clearance between the newly built railway and the existing, for instance, the existing river, the clearance must be sufficient. This is the crossing constraints. And finally, the construction constraints mainly refers to the maximum bridge height and the maximum tunnel length. These constraints are set for economical purpose or limited by the current construction technologies. These are the multiple constraints in this study.